So today I'm basically going through section 3.2, which is linear equations in two variables. So I know that the order that we're doing the class, like, it was kind of weird because we skipped this chapter and then we did like quadratic stuff and now we're going back to it. And the only reason we're doing it in this order is because this is basically the same order that you're going to see it in college algebra. So
Okay.
we're just trying to be consistent, you know?
Gotcha,
Like,
gotcha.
basically, the second half of college algebra is graphing. So this class is kind of doing like the first half of college algebra. Not everything that you see in college algebra, but at least to get you the basics down. And so, you know, we've gotten to the point like, okay, we're going to start introducing you to graphing. So those last couple weeks are kind of getting you familiar with most of what you're going to be doing in college algebra. So 3.2 is all about linear equations in two variables. So this is where we're going to start graphing lines. And that's basically what the focus is lines. And this is probably the most kind of graphing that you need to do if you're in like business. Mostly you graph a lot of lines. So we have a specific form for an equation, a linear equation in two variables. So first, two variables, because instead of just x that we've been working with, we now have x and y. So we have two letters, so two variables. And it's linear because it graphs a line. So that's where the word linear comes from, is that it literally, when you graph it, you get a line. Linear equations never have exponents on the variables. So just like when we were solving linear equations with x, there was no exponents. The same thing applies when you have x and y. So there's no exponents there. So the rules apply as what we did before. We just now have two variables. We have this form ax plus by equals c. Those capital letters are basically replaced with numbers. So your only actual variables that you work with are x and y. And those correspond with our graphing. When we graph something in 2D, we have a horizontal, which is x, and then a vertical, which is y. So that's why we use those letters, because that tells you, oh, I'm probably going to graph this. We're using those specific combinations of letters. Now, what makes a linear equation in two variables different from a linear equation in one variable is when you have two variables, you can't just solve for x and get a number, because you have a second unknown. So there are actually infinite solutions. The rule is, if you have more variables than you have equations, you're going to have infinite solutions, because you don't have enough information. If you have one variable and one equation, you can solve that. But with two, you can't get a single number as your solution. So we have infinite solutions, and then the way that we show those solutions is by graphing, basically. That's how we show what the solutions are, is by looking at it graphically versus writing down every single possible number, because that would be silly. So that's sort of when we talk about solutions with x and y. There are infinite ones, and you can find specific solutions, but you can't find all solutions. So you can find a solution, and there's as many as you want to find. Now, when we have the x and the y on the same side, we call that the standard form of a line. And it's sort of like how we had standard form when we were looking at quadratic equations. Everything was on one side. All the variables were on the same side. It's the same sort of thing here, where all the variables are on one side. The only difference is that we don't have it equal to 0, but it's similar. There are other forms of a line that you'll learn later in the chapter. There's a slope-intercept form and then point-slope form. Point-slope form is helpful for the discussion for this week. So it's each form has a different use. You know, they're there for a reason, and some forms are easier in some situations than others. So the standard form, we just put the x and y on the same side. So that's all the definition part about linear equations. So we can't solve something with x and y, but we can check to see if something is a solution. And
Oh, okay.
because, like I said, there's infinite solutions. So we can't actually find x and y, but if I give you an ordered pair, you can determine whether those work in the equation or not.
Oh, okay.
So these ordered pairs, oops, I'm highlighting. I don't want to highlight. These are always x, comma, y. It's always written in alphabetical order. So when you're given an ordered pair, that first number is telling you what number you're going to plug in for x. The second number tells you what number you're going to plug in for y.
Okay.
So for the example on the left, x is 4 and y is -3. And so to check if it's a solution, we plug it into our equation here. So in my equation, I have 4x, so that's 4 times x. So I'm going to replace x with what x is equal to, which is 4. And then I'm just color coding here so that you can see what's being plugged in. And then we have 5y. And 5y means 5 times y, and y is -3. So I'm going to replace y with -3. And then this equals 1. And then what we do to check to see if it's a solution is just we follow the order of operations on both sides and then see if you get the same number on the left as you do on the right.
Okay.
So on the right, we don't have to do anything. It's just a single number. But on the left, we're going to have to multiply in order to simplify this. So we can do 4 times 4, which is 16. And then 5 times -3 is -15. So we have 16 plus -15. So you add those together, and that gives you 1. So we end up with 1 equals 1. And if the left side is equal to the right side, that's good. That means it's a solution. So 4 -3 is a solution. So that means it works in the equation. It's just one of the many infinite solutions that we have.
Okay. -3.
So the second example I have, oh, go ahead, ask your question.
If that was a test question, that's all we have to do is put the 4, -3 is the solution.
Yeah, if it was like on a test, usually they'll say, is it a solution or not a solution, and there would be like a checkbox or like a, you
gotcha.
pick which one it is. Yeah.
Okay.
And then they might like say, okay, what is the ordered pair? That's a solution. So, but they usually try to give you, I think the checkbox is usually to make it, you don't usually have to type a whole sentence.
Gotcha.
Now I have a second example here with fractions because I know that people struggle with fractions, and I thought let's do some with fractions.
Yes, that's me.
Yeah. So, and this one actually, because of the particular numbers that we have, it's not going to be as hard as you think. So first, we have to determine what our x and y are that they're giving us. So x is 1/4, and y is -2/5. So again, it's just alphabetical order, which one's x, which one's y.
Right, okay.
So I'm plugging it into the same equation. So I have 4 times x, and in this case, x is 1/4. So you have to be careful you're replacing the right number, because especially on the left, the example on the left, we had 4 twice, 2 different places. You need to make sure you use the correct one that you're replacing.
Okay.
And then we have 5 times y, and y is -2/5. And I have to put this in parentheses to show the multiplication.
Right.
And then equals 1. So we've got whole numbers multiplied by fractions. So a whole number times a fraction, you multiply the top. So that 4 times 1/4 is going to be 4 times 1, and then it's over the denominator 4. So that gives us 4/4.
Okay.
And then 5 times -2/5, you do 5 times -2, which is -10, and then our denominator is 5.
5.
And now we're going to reduce these. So 4 over 4 reduces to 1. -10 over 5 reduces to -2. So we get 1 plus -2 equals 1. And then we need to add 1 plus -2, which is the same as 1 minus 2. That gets us -1. And so we get -1 equals 1, which is false. We get a contradiction here. We got something that's not true. So
Okay.
I like to put just a little X to indicate that it's not true. Or you can write the word false. So if you get something that's not true, you get a contradiction. That means it's not a solution. It does not work in the equation. So not everything works in equation. There's infinite solutions, but that does not mean every possible number works. There's only certain ones, but there's an infinite many of those.
Okay, exactly.
It sounds confusing.
Until you start doing more.
Right. Any questions?
So far, no.
Okay. So we're going to kind of move one step further now, looking at the graphing. And the way that we graph these is we basically find solutions, and then we plot those ordered pairs on a graph, and then you connect them with a line. Okay. So in this example, we're like, normally you'd be like, well, how do I know if a number is a solution? In this example, you're given hits. You're given a table to fill in where you're told one value and you have to find the matching value.
Okay.
So we have x plus y equals -2, and then I've got my table, and it's a table of x and y. And so everything under the x column is the number that you plug in for x. Everything under the y column is the number you plug in for y.
Okay.
And so we do this row by row. So the first row has 1 in the x column. So this is telling us that x is equal to 1. But we don't know what y is equal to because we have a blank there, basically. So what we do is we plug in what we know into our equation. So our equation is x plus y equals -2. We know that x is 1. So that's 1 plus y equals -2.
1 plus y equals -2. Okay.
And so we should just to make it clear that that 1 is going basically where x is. And now we have an equation that I can solve for y, because I have one variable here. So I can solve this equation and figure out what y is. So I'm going to subtract 1 from both sides. And y equals -2 minus 1, which is -3. And so I'm going to put that in my table, because now I've determined that my matching value is -3. Actually, make that a little darker there. So once you fill in one row of the table, you graph that point. So I go over to my graph here, and I go to 1 on the x, and then I'm going down to -3, and I'm going to put a little circle. And so that's my first point.
Okay.
Basically, what we just did is we found a solution. So we found, I accidentally picked black. We found that a solution is an x value of 1 and a y value of -3. So that but this table is another way of writing a series of ordered pairs. So if you're asked to put it in like an ordered pair form, you can do that based off of the information, because it's always x comma y.
Okay.
So once you fill in one row, then you move on to the next row, and you say, well, what information did they give us? So row 2 here, we don't know x, but we know y.
Mm-hmm.
So let's tell us the y is equal to 0. So I use the same equation, but in this case I don't know x, but I can replace y with 0.
Mm-hmm.
And actually, I love when I get to plug in 0 because it makes it really nice, because this just gives us x equals 2.
Correct.
So I'm going to fill that in my table, and that's equivalent to an ordered pair 2, 0, because we have to put it in alphabetical order. And then I'm going to go to my graph, and then that's 2, and then I'm not moving up or down because that y value is 0. So I've got a second point here.
Question.
Yes.
That wouldn't be a -2?
It would be a -2. Thank you for catching that. I lost my negative. It's been one of those days. Okay, so it's
That's okay.
-2. I'm glad that you corrected that before we went all the way. Okay, so that makes my graph look very different because that pointed us in a very
Right, because I kept looking, I said, wait a minute, where's the negative?
Good, yeah. I mean, everybody makes those mistakes, even me.
Right, exactly.
Okay, so now we move on to the next row. So I'm going to just kind of put this over here. I'm not organizing this very well, as long as there's some way that you're, I'm just trying to think out of the screen.
No problem, paying attention.
Yep. So here they're telling us that x is equal to -3, and then we're trying to figure out what y is. So same equation. Replace x with -3 plus y equals -2. I made sure I actually wrote my -2 there. Why did I put an extra plus sign though? I don't know. Okay, so I need to add 3 to both sides. So that gives me y, and then -2 plus 3 is 1. Okay. So that gives me an ordered pair, -3, 1. Okay. And once you have, so when you have 2 points, like the goal is that these should form a line when you connect them. So when you have 2 points, It's hard to figure out that you have a mistake. But once I've caught that third point, then you can tell. Like if we had not caught my mistake and I had something like this, that would say, okay, you've got a problem, because if you connect those, they don't make a line.
Right, exactly.
So you can always double check yourself, because they're supposed to make a line when you connect them. So if they don't look like they're forming a line, there's a mistake somewhere. Okay. So the general rule is, when you're graphing these, pick at least 3 ordered pairs, because that way you can always make sure that you can check yourself.
Okay.
Only 2 is required to make a line, but if you make a mistake with those 2, you won't figure it out until you do a third one. So 3 is like a good amount to do. Okay. Now here we've got 4 just for good measure, so we'll do the last one here. In this case, y is equal to 2, and we don't know x. So I've got x plus 2 equals -2. Subtract 2 from both sides, and then x is -4. So I get an ordered pair of -4 and 2. It's always good to put it in a table. It helps to read those ordered pairs correctly. Right. -4, 2. Good. So you can see that they're making a line. This is a good sign. So once you've got enough points, then you basically connect them. And this is the part that I'm not that great at doing by hand, but I have a little grid here to help me follow it. Okay. So graph paper is as helpful when you're doing this by hand. The nice thing about doing this online is that they give you the graph for you. So all you have to do is basically pick the points. And then I believe what Connect Math has you do is you pick 2 ordered pairs, and then it will automatically connect them with a line. So it makes it easier. You don't have to hand draw the line. It will connect them for you.
That's good to know.
Yeah, because hand drawing is not that great unless you have a ruler, because, I mean, my line is not perfect, but you get the idea. Now,
yes, definitely.
I put arrows on here just to indicate that it keeps going, because it doesn't just stop. The line goes on forever, and that's how we have infinite solutions. But any ordered pair, any point on that line is a solution. So, like, even though this is not one of the points that we were given, it's on the line, so that's a solution. So you can make infinite dots on there. So anything on that line works in that equation.
Gotcha. All right. That makes it easier to understand.
Oh, yeah, I love graphing because it's visuals for me really helps me understand what's going on. And so I just like to have graphs, because then I can like try to think about, well, what does this mean? You know, what information is going from, like, here, if you read this from left to right, this is telling you that as x gets bigger, your y values get smaller if you go from left to right.
It does.
So it's telling you that things are decreasing here, because we usually read these from left to right. So if you had like real data, like this week, your discussion is to graph the relationship between your forearm, which is between your elbow and your wrist, and then your height, and get that with like 2 people. If your graph is going down, that tells you that as your forearm increases, your height decreases, like it shrinks, which doesn't make sense, you know?
Right, it doesn't.
Now, there are some, you know, I've actually done my coworker, when we use our order pairs, we actually get something that decreases like that, which is weird because the human body's not perfect, you know. But you'll find most people will have something that increases, because it makes sense as your arm gets longer, so will your height, because you're trying to stay in proportion, you know.
Right, exactly.
So that graph gives you some information, and then you can visually say, oh, okay, well, what does this tell me?
Right.
Okay. Here's another equation. Now this is a different form of equation. So the one we saw, all the x's and y's were on the same side. Here they're not. This is a special form that's called slope-intercept form.
Okay.
And this is a form that's really nice for graphing. Now I'm not going to go into how to use this for graphing. We're going to do the same techniques that we're doing here, where you're plugging in numbers. But I think it's in the next section, 3.3 or maybe 3.4, where they introduce this form.
I want to say it was 3.3. That's what I think it is.
It might be 3.3, but it makes it a lot easier to graph. It's the best form for graphing.
Okay.
So, you know, each little thing has you know, what it's good for. Its slope-intercept form is great for graphing.
Okay.
I'll kind of show you how to do that form later, but right now we're going to fill in our table again. We're going to follow the same sort of thing, but we've only got 3 points here, because that's as many as you need in order to make sure that you're doing all your work correctly.
Right.
So we'll do the first row, where x is equal to 1. So I've got y equals 5 times x, which is 1, plus 1. And this is really nice because I don't have to do anything on the left side. 5 times 1 is 5, plus 1. It's just really easy to do the math here. If you just keep working your way down, so you only have to do stuff on one side. And so that's one of the reasons why we think it's really good for graphing, because if you have an x value, you just plug it in, and then you don't have to solve. You're just doing some simple math here.
Right.
Now, Now,
So it's 6.
on my graph here, we have to be careful because you want to take a look at what it's counting by. So the previous one, it labeled everything. It was counting by 1, and that made it really easy.
Right.
Here, it's not labeling every point. So you have to figure out, well, how much is a tick mark? So you have to count 1, 2, 3, 4, 5. So there's 5 tick marks to get to 5. So that tells you each one is counting by 1.
1. Okay.
Yeah, you can't assume that to be true because sometimes these graphs will count by 2s instead. Sometimes they count by like decimals. So you always want to double check and see what is it counting by so that you can figure out what each mark stands for. And they don't always count the same in either direction. So sometimes they'll count by 1 and like horizontally, but maybe 2s vertically. So you do have to pay attention to that. Now, this one we're counting by 1s in both directions. So each tick mark is going to be 1, and that makes it easier. But you always need to double check when you're given a graph just to be safe.
Okay.
So now that we know that each tick mark is 1, that means I can graph my 1 and then 6. So it's a little harder when you have a smaller graph like this. But you have to just kind of fill in the blanks and make sure that you're right at the right number.
Okay. So 6 and right there 1. Okay.
Now I'm going to do the second row here where we're given y is equal to 1. So this is where it's a little annoying to have slope-intercept form because now I have to do some solving. Because if I plug in 1 for y, now I have a more complicated equation to solve.
Correct.
So I'm going to leave my x on the right, and I'm going to subtract 1 from both sides. 1 minus 1 is 0, so I have to make sure to write 0. It doesn't just disappear. I have to put something there. And then I have 5x. Then I divide both sides by 5, and 0 divided by 5 is 0. So I get x equals 0, or 0 equals x. So 0 is on the x, and then 1 is on the y. So that gives me that point right there.
Okay.
And then we've got our last one. I'll just put this over here where x is equal to -1. So this goes back to the easy part because all we have to do is plug it in. So we have 5 times -1 plus 1. So y is equal to, that's a -5 plus 1. And then y is equal to -4. Okay. Let's make that a little darker there. So I'm at -1, and then I need to count down to -4, which on my graph is really, really tiny here.
I see.
And then I do my best to connect these. And then that, oh no, I actually erased it. I hit my erase button on my canvas.
Oh, okay.
It's not perfect, but it's good enough. You get the idea.
Yes, I do. Very close.
Yeah. This is why we do not encourage you to graph by hand, because if you're trying to graph by hand, it's really easy. You can't get it perfect. But technology, we can graph it on a computer, and it can get it perfect, and it's wonderful.
Okay. But doing it by hand is a little tough because it won't be straight.
Yes. Yeah. I mean, it's good to practice by hand so at least you understand what's going on. But yeah, once you get the idea, then using technology can make your life a lot easier. And I'll show the website that I use for that we'll use for like the discussion.
Okay.
but I'll do it that at the end.
Okay. So here we're not given a table. So a lot of questions I get with graphing is, what do you do if you're not given a table to fill in? Like, how do you
Right.
know what numbers to plug in? Well, you can plug in any number you want, honestly.
Oh,
You can decide, do I want to plug numbers into X? Okay. Do I want to plug numbers into Y? Okay. What number do I want to plug in? You can choose any number that you want. It's freedom, basically.
oh wow. Okay.
Now, there are some recommendations that I would make. So here we've got something that's in standard form, because the X and the Y are on the same side.
Okay.
So just again, that form is AX plus BY equals C. So when you have something in standard form, I recommend making the following table. And I usually only use 2 points for this. And I mean, you can do a third one, but I just do this table where one line you're finding 0, you're using X equals 0, and then the other one you're using Y equals 0.
Okay.
And I do this because plugging in 0 when it's in this form is really easy. And this saves you work. Like, this is the easiest way to graph.
Okay.
So let's start with the first row where X is equal to 0.
3.
So I'm going to replace X with 0. So that's -3 times 0 plus Y equals -6. So -3 times 0 is 0. So that basically just kind of disappears there.
Exactly.
And then we just get Y equals -6. And so then I can plot that point. And so this is the same grid as the previous example. So we're still counting by ones. But, you know, I didn't really have to do anything other than multiply by 0. And that was pretty simple.
Exactly. See why. -3.
So the second row, when you make Y equals 0, it's going to be just as nice. It's going to be a little bit, you know, one extra step, but not so bad, because it's going to be -3x plus 0 equals -6. And so that gives you -3x equals -6. So then you just have to divide both sides by -3, which, you know, it's not that hard. This is like the simplest way to solve. These are the easy problems.
Right.
And so -6 divided by -3 is a +2.
Mm-hmm.
And so I can put that, and then I can connect these with a line, and it's a little harder to get a perfect line with only 2 points, because if you're slightly off, you could be very off, but it's good enough for our purposes by hand. You know, you get the idea.
Yes. And help me out.
Yeah. So whenever X and Y are on the same side, this is what I recommend you do for solving, because it's just it's the easiest way to do it without having to do a lot of work.
Okay.
Now here we've got the other form. We're back to the slope-intercept form.
Okay.
And so when using slope-intercept form, I do recommend 3 points. And I usually plug in -1, 0, and 1. Because those are X values that it's easy to plug in and multiply by. It's really easy to multiply by -1. It's easy to plug in by a +1.
Okay.
Now there is one thing you have to consider, is if you have something like a fraction like we have right here. So when I pick these numbers, if the fraction is 2,
then I'm going to multiply these numbers. If like the bottom is 2, I'm going to just multiply these all by 2 because that will make sure any math I do doesn't have a fraction.
Oh, okay.
So normally I would plug in -1, 0, and 1, but if there's fractions involved, I'll multiply those all by 2, and instead I'll plug in -2, 0, and 2. And I'll use those numbers instead. And those will allow us to kind of get rid of the fraction easily, so you don't have to worry about fractions.
Oh, that's good.
Yeah, it's a nice little trick.
Let's see. Yes, it is.
So
Alrighty.
we'll start with x equals -2. So I just plug that in. I have y equals -1/2 times -2 plus 3. So we have a fraction times the whole number, so you multiply the tops of those. So first we've got a negative times a negative, so that's going to be positive. And then 1 times 2 is 2. So we get 2 over 2 plus 3. And 2 over 2 is 1. So this is really just 1 plus 3, which is equal to 4. So I'll plot that little point there.
Okay.
Now I'm going to plug in 0. And this is really nice. This is where slope-intercept form is wonderful. Because when I plug in 0 for x, basically that whole thing disappears.
Correctly. Mm-hmm.
Oops, just get 3. And so that makes it really nice to graph. So that's why I always choose 0 for my x when it's in this form, because it's easy calculation.
Yes, it is, definitely.
And then let's do our last one with x equals +2. So y equals -1/2 times 2 plus 3. So -1/2 by 2, that's going to give me -2 over 2 plus 3. That reduces to a -1 plus 3, which gives me 3 minus that, a +2. So 2, 2. Okay, so then I plot that. In that calculation, again, we didn't really have to deal with a fraction because of the numbers that I chose.
Right.
And then, oh, that was a really bad look. I didn't even go through my third one. There we go. I'm afraid to make it longer and have my line really bad.
That's perfect.
Yeah, it works. So when you have an equation when it's in this form, if you follow these guidelines, it will make your graphing by hand easier.
Okay. So this is the slope-intercept form.
Yes. And it's called this form, that word intercept, this is something we learn about here, intercepts. So these are where the graph crosses one of the vertical or horizontal lines, the axes. So it's called an intercept. So the x-intercept is where it crosses the x-axis. The y-intercept is where the graph crosses the y-axis. And to find the intercepts, you plug 0 into the opposite variable. So to find the x-intercept, you replace y with 0. To find the y-intercept, you replace x with 0. And then you get an ordered pair where you've just got some number in these gaps, but 0 is going to be the other spot.
Okay.
So you'll have a number for x for an x-intercept or a number for y-intercept.
Okay.
So if we go back to the slope-intercept form, when x is 0, this gives us our y-intercept. And that actually is in our equation as well. So slope-intercept form is called that because it gives you one of the intercepts in
Okay.
the equation itself. And so I'll go back to our other one that was slope-intercept form. It says +1, and you can see that it crosses the y-axis at 1. So
Yep.
I usually just abbreviate that int. So that's why it's called slope-intercept form, is because whatever's number is added on, that's where it hits on the y-axis, which makes it
Oh.
really nice because you can look at the equation and you know, hey, that's one of my points, and you can plot it immediately.
Okay.
Now, the other way that I graphed when we had standard form, here, I picked an x of 0 and a y of 0. Those were the intercepts.
Mhm.
So when y is 0, that's our x-intercept. And then when x is 0, that's our y-intercept. So this is also called graphing. I really don't like this purple. Oh, shoot. Oh, too far. I was just trying to erase my purple. It would just. Oh, well.
Got
Graphing using intercepts. Because instead of just picking any points, we are deliberately picking where it's crossing on the axis because those are easier to graph.
Okay.
So
Right.
one of them is the x-intercept and the other one is the y-intercept, and they're named based off of which number is not 0. Basically. Now, sometimes you can have it going through the origin 0, 0, and it's both an x and a y-intercept. Those are kind of tricky problems, but for the most part, they don't normally do that. So that's why I chose to graph by this way. So this example is a given graph, and we're going to just use the graph to read what our intercepts are, the x and the y intercepts.
Okay.
So the x-intercept is where it hits on the x-axis. So that is going to be right here. Now it's not hitting on a tick mark, so we have to kind of guess at what that is. And you want to make it the easiest number that you can guess. Like it's, if I count my tick marks, it's -1 and -2,
like a 4?
-3, and -4. So it's in between -3 and 4. So we don't want to make it a whole number because it's clearly in between there. But we can assume it's halfway between because that's, you know, we can say, okay, it looks like it's halfway between -3 and -4. So that would be at -3.5. And then our y value is 0 for an x-intercept. So you're not going to estimate something like -3.459 or something crazy like that. You know, you want to kind of like, okay, well, it's about halfway, so we're going to say that it's halfway.
Right. That'd be y.
And then the y-intercept is here, which does go through a line, which makes it easier. For y, the first one is always 0, and then it looks like on the y, I gotta make sure I count these right. 1, 2, 3, 4, 5, 6, 7. So it's at -7.
7. Mm-hmm.
So I had to double check that I counted that because the -5 is kind of hard to see which line that's with. So it's like I just want to double check.
It does. It's so small.
Exactly. Yeah. So that's when we're estimating, is we're basically just saying, okay, what are the ordered pairs for these? So second graph here. So x, that looks like it's at 1. So that's going to be 1, 0.
And then our y-intercept is, okay, I gotta count these again. 2, 3, 4, 5, 6, 7. That's also at 7, but now it's a positive 7. So that would be 0, 7.
Okay.
Okay. Let's see, I'm going to skip my next examples and then go back to them if we have time. Because I think I might have too many examples. And I do want to make sure I go over the graphing and our online system as well. It really is. So there are some special types. So we have seen all of the lines that we've seen so far slanted. You know, they've got some sort of angle to them.
Yeah.
But we can have special, we can have a straight up line, a horizontal, or a vertical line, which is straight up or down. And then we could have a horizontal line, which is left to right. So make sure oh, that was not horizontal. There we go, that looked better. So we can have those where there's no slant at all, basically. They're only going in one direction. And those equations are special because those have one variable. So one variable. So that means every equation where we solve for x and that was the only variable, if we graphed those would be special. Any equation where you have an x and you don't have any y, that's a vertical line. So anything that we had solved with linear equations where we only had x, if you graph it, you get a line straight up and down. Because if you're in here, you've got an x and y, any straight up or down line is hitting the x-axis. So that's why it's an x equals some number, basically, because it's going through x. That's what makes it vertical.
Oh, so you okay, so you never have a y-intercept with that.
Exactly. The only thing that is if it goes through x equals 0, because then it is the line at y. So that's a special case.
Gotcha.
Now, if you have a y equals, that's where you get something that's horizontal, because it's touching, you have a y intercept, but you don't have an x. So a lot of people get confused which one is horizontal, which one is vertical. And think about, these are telling you your intercepts, and then draw a line through that that's even horizontal or vertical, and that, you know, kind of is perpendicular to the axis, basically.
Right.
So these are easy to graph because you basically just figure out, well, where is the intercept, and then you draw a straight line through there. Like they're like the easiest kind. The hard part is remembering which one is which. So
right, if it's the x or the y.
Yes. So here I have graph y equals 3. So what I do is I say, okay, y equals 3. This is a y-intercept. So I'm going to put, you know, a circle or a dot at 3 on the y-axis, because that's where y equals 3. And then to graph this, I say, well, I need to be perpendicular to the axis. So this is not going to be horizontal, because then I'm just going straight up and down through all of those numbers. So this has to be a horizontal line. So y equals is always horizontal. And so we have a y-intercept. X is 0. We don't have x. And our y is 3. But there is no x-intercept because we don't cross it there. We don't cross it ever. It just does not exist.
That's true. That's true. Intercept. So, but we'll write the answer 0 for x and then 3 for the for y, correct?
Yes. Yeah. So we have one intercept. We just don't have.
Okay. Okay.
Now, sometimes they don't give you these equations solved. Like, you may not see x equals a number. You may see x plus 4 equals 0 or something, or x plus 4 equals 10. When you're graphing something like that, if there's only one variable, you need to solve it first.
Okay.
So we need to solve x plus 4 equals 0 first before we graph it, if there's only one variable. So I will subtract 4. And so this gives us x equals -4. So that means I'm going to put a dot and -4 on the x-axis. And then because I want it to be perpendicular, this has to be a vertical line going through here. So here we have an x-intercept. As it crosses x at -4, and then y is 0. But we have no y-intercept, because it never touches that y-axis.
Right. Right there.
So what I encourage you to do is to, when you're graphing these by hand, you can always check your answer with technology. So the website that I recommend, and I'm going to pull it up if it, oh, it's my Chrome is being slow again. I'm going to wait for it to.
No problem.
Oh, it was good for a while. I thought, oh, maybe its issues stopped, but no, now it's just going to be a little slow.
No problem. So this is what I would do when I be doing my discussion, correct?
Yes. So the discussion is more than just graphing. So for your discussion, you measure things, and then you get to have fun. You can choose somebody in your house, or you can even just take a classmate's numbers or something like that. And so you get to measure. It's kind of fun because it's kind of interactive. And so what you do is you find your two ordered pairs and you find the slope between those, which I believe is covered in 3.3. Then once you find the slope, you find your equation of the line using point slope form, which I think is 3.5. And then you graph your equation to see what it looks like and what it's kind of telling you.
Okay.
So there's like 3 pieces to it, and let's see. Yeah, I'm going to open a different browser. I also have Microsoft Edge installed, so because that I have not had problems with, so we will we'll do that one so that we don't just wait forever for Chrome to decide whatever it's doing.
Right, no problem.
Okay. So this website that I love for graphing is called Desmos. It's DESMOS. There's also a phone app if you want to like graph it on your phone. So it is basically meant specifically for graphing. If you go under math tools, there's other types of calculators, resources. If you want to like practice tests and things like that, it's really nice. I've actually met the guy who created this website. Very nice guy. He's doing really a lot of cool. Yeah, I was so excited when I met him. I'm like, oh man, I feel like I met someone famous in the math world, So you just start with your graphing calculator. So you just click this button, and then it will pop up eventually. And so this is what you see. Now what's kind of nice is if you hit the 3 drop downs here, it gives you some examples if you kind of like want to explore. Like, lines, we talked about slope intercept form. So let's say I just open this up. So it gives you an example, and you can kind of play around. It has these sliders, and you can see as I change this number, what happens to my line. So you can kind of explore and see, oh, what parts of the equation change my graph, which is fun.
Okay.
But we're going to do a new blank graph because I want to show you sort of how to use this to check your work. So what you do is first, so I've got my cursor in this box thing. And what you do is whatever ordered pairs that you got from solving your tables, whatever, you put those in. So I'm going to just make up numbers. So let's say I had a graph and I got 1, 2. Like you just literally type in exactly how you would put it on the paper. You use your parentheses, you put commas in between, and then it will plot that point for you.
Oh.
And then to get to a new line, you can hit enter, and then you can put in a second point, 2, 6 or something like that. And then it will plot that. And you can add labels, so you can name it, like if you're, when you're doing your discussion, you can, label it you, your daughter, whatever. So you can add labels to those points. If you click and hold, and let go, that gives you options to change the color. So you can change the color. You can change what the dot looks like. So it has some cool things. So, that's if you want to play around with it. So for the discussion, you'd be putting in ordered pairs.
Right.
And then you also type in an equation, and you can put it in any form you want. So like the vertical line, x plus 4 equals 0. I can just literally type that in, and then it graphs it. So you can see it in green here. And if you want to get rid of things, X's, and that just disappears. If you don't want the graph, you click once, it will disappear, but it still saves it right here. So I can graph things with X and Y on the same side. I think this is one of our equations. So you just type in exactly what you see, and there's your line. I can do a Y equation.
That is kind of cool.
Yeah, and it's nice. You can check your work here. You can put in different equations and see, okay, did I do that right? Now, what's also nice is, so let's say I put in this equation. If you click on the line, so it's got some other options. If I click and hold here, I can make it like a dash line or dot if I want. But if you click on the line here, and then I click and drag, I can see ordered pairs that are solutions. So you can see that all of these ordered pairs are solutions because they're all on the line. And it highlights, it marks for you the intercepts. So here we have an x-intercept at 2, 0, and a y-intercept at 0, -6. So you can double check your intercepts as well because it will mark those for you, which is really nice.
Oh, that's kind of cool.
You can zoom out. You can zoom in. You've got these options. This settings, the wrench here, this is probably more than you need to really know, but you can add arrow kind of things if you want. Turn off grid lines. You can change what you want to count. So let's say I want to count by ones. So I just type in 1 there. And just to make sure that I'm counting by ones. But let's say I wanted to count by like 0.5. You can see it added more grid marks if I'm counting by something smaller than 1. If I wanted to count by 5s.
Oh, I see that. Okay.
Yeah, so you can see that it's kind of adjusting what you're counting by based off of what you're putting in here. And you can add labels. You can change these. So if I wanted to instead center it from -10 to 10, I can change those in. You can change where you're centering your graph. You can have all these settings here. And then what's really nice is, say you want to paste your graph into a discussion, because you want to share your graph after you've done it, and when you're doing your discussion, to make sure that your line is correct. So you click this button here that says share. So you can either copy the link, or you can embed, there's an embed like HTML that you can put in our discussion. There's an HTML editor, you can do it that. Or if you click export image. And it's loading. So you see this right here. So what I do is I copy, and
Yes.
then let me open up a discussion.
Because I was wondering how we was going to do that part. Okay.
Yeah.
So.
Oh, I'm gonna try to pull over. I don't even know what class I'm in. No, I've got to relog in. Okay, let me just log in again. I'm sure the logging in takes just as long for you guys as it does for me.
Yep. Especially when I've been on it for a little bit and it logs me out.
Yeah.
Yep.
Okay, so this is my pre-calc class. It doesn't matter what class I'm in. I just want to show you how. So I'll just create a thread.
Okay, no problem.
So I already went and I copied it. So if I right click, where's my paste? Okay, let me try again. Right click, copy, go back to, there we go. Okay, I right click and then I got paste. I just click, okay, I gotta use the keyboard shortcut. So paste is Control V. V is the paste. I don't know why it's that.
Right, Control P.
I do Control V. So you're gonna get this option. I always say to keep formatting just to be safe, but there it is. So that will be nice. You can just copy it directly in. If you did choose to do the embed, this is our optional for the options for HTML if you wanted to mess around with that. And then to type the math for the discussion, this button here, the square root symbol, does math. So you would click this button, and then you get this other window that pops up.
Okay.
And then you can type your math in here. So like I could do y plus y equals 5x plus 10, and then I hit enter, and then I can do my next line, like let's say y equals, and plug it in some number. So you can type your math, and you just keep hitting enter until you're done. It has a button for a fraction, so you have fractions, you just hit this button right here. So like our slope equation is m equals, and then it's a fraction. So I'm going to hit the fraction button, and then the slope is y2 minus y1. So I type y, and then the 2 is actually underneath the y. It's a little tiny thing, so you hit this button right here, which puts it under. It's called a subscript. And then I can put in the 2. And then I hit my arrow to get out of the little under piece. And then I have my minus, my y, and then I hit that button again. And so you can fill in and you can do fractions this way. If you want a color code, you can highlight it. And then you then say, okay, I want this to be blue. And then now that's going to be blue, you know. So you can enter all the math you want. What I recommend is any words, like any sentences, don't write it in here. So only do the math and then hit OK. And then you can see it shows up. And then what I usually do is I make sure I hit enter. So and then I like type some words, and then I hit enter, and then maybe I'll do more math. So that's how you're basically going to do your discussion for the week, is you get to kind of play around with some of these features that we have on the editor that we've never used before.
Right, exactly.
Yep. So that, and so that's everything you need to know about the discussion, and then using this website. You can even download it as a picture if you want, but you don't need to. But you can use this to double check that you've done things correctly, to double check your graph and make sure it goes through your points and things like that.
Okay, that's good. Very helpful.
Yeah, and I think I have
I was wondering how.
I think I have a second video on showing this, but you can never have too many videos on how to do something. So.
Exactly, that's true. Very true.
Yep. So
thank you so much.
Yeah, so that's basically everything that I wanted to go over. Do you have any questions for me?
No, ma'am, not at this moment. You answered my question.
Good. Excellent. So, all right.
After that.